Hello, it's Mr. Brown. This podcast is for CNT140. This is going to cover Chapter 1. Now, quick word of caution on this one. This chapter looks rather large, but the author, I think, tries to introduce all the major pieces of wiring. And what I'm going to continue to remind you is this is an overview of kind of the whole book. Each of the following chapters are going to take a slice of what this author introduced and go in each piece a little deeper. So we're going to treat it as an introduction and overview just to kind of get the ball rolling. All right, here we go. We're talking about designing LAN wiring systems. So, some of the objectives here are going to be understanding the installation, some of the other aspects of it, installability, reusability, maintainability, that sort of thing, what it actually looks like, some costs of it, that sort of thing. All right. First thing, LAN wiring system of structured cabling we use to interconnect computers, printers, routers, switches, other devices. This is the actual physical link of our network, kind of like the layer 1, if you will, connecting all the computers, printers, access points, switches, routers in our network. So this is the functional piece of our network, I should say, the piece that makes the whole network function. It's important that we plan, specify, implement this that's going to provide a reliable service. Absolutely. As we go this semester, we're going to slowly build up a project where we design a physical structure for a network. The appropriate component parts for our network, plus good installing of that, good workmanship, which again, we're going to pick up components all semester for our project, and then we're going to be doing labs all semester where we are showing the proper way to install this. So the end result should be this cabling meeting our performance demands, which again, later this semester, we're going to hook up meters and check our performance. Does it meet what we need it to do? And we should also be planning for future growth. If I need 2 network outlets right now, I probably want to put in 4 so I have a little bit of room for growth down the road. The author introduces the idea of evolutionary and revolutionary advances. Well, real quickly, our LAN wiring evolves as networks change and we need more bandwidth. Small changes occur to evolve the cabling so we can handle more bandwidth. But occasionally, a major shift happens where we need to go from gigabit to 10 gig, if you will, and that might require a total cable replacement, where I literally need to pull out all my cabling, put in a new type of cabling, new patch panels, new outlets, new jacks, new patch cables, all that. That would be a revolutionary change. Well, our main focus of our LAN wiring is to keep up with evolutionary changes. If I put a LAN wiring system in, I'm hopefully going to get 10 years, 15 years out of it, maybe 20 if we're pushing. And then we would make a massive change. All the cabling comes out, new cabling comes in to handle the massive bandwidth upgrade that we're doing, that sort of thing. So the author is introducing this idea. When LAN wiring, we started doing LAN wiring over twisted pair, there was very little known about its role and its performance and that sort of thing. So the real interest initially was to get rid of the bulky coax that was being used in Ethernet networks, coax bus networks if you think back. The phone cabling was a lot smaller, a lot easier to deal with, a lot easier to terminate, but not much was known about its performance. So initially low data rates was okay, but as the data rates got higher above modem bandwidths, if you will, it was not acceptable. So changes had to occur in the structure of the cabling, more twists per foot, better impedance, those sorts of things. That's when our twisted pairs we know it today kind of came from. That's where it kind of got started. What needed to happen then was there needed to be performance grades or performance specs determined for this cabling, and that's where the categories 3, 4, 5, 5E, 6, 7, all that stuff came from. These categories then were denoting what is this cabling able to support, what is this cable able to support bandwidth wise, performance wise, and along with that, specs for our connectors and so forth and terminations of that cabling. And again, along with that, workmanship to properly install this stuff so it would work, it would perform, it would meet the performance specs that we need. All this evolved to get to our LAN wiring system that it is today. Again, coming from the coax bus networks to, category 3 phone networks to moving on to twisted pair category 5 like we would have today. All that has slowly evolved over time. All this careful planning of a standards compliant cabling system is called structured wiring. We're going to get to standards as the semester goes on, but just think of this real quickly as if I'm going to have my car drive on the road, it needs to be inspected. So I take it to the garage, and the mechanic checks for certain things, proper tire tread left on your tire, proper amount of brake pad left on my brakes. All those things are standards for safety so that my car is certified to be on the road. While the same thing is true in networking, I need to have a standards compliant cabling system so it meets all the things of like performance criteria, fire codes, putting cabling in my building, all those things. All that careful planning to our standards ensures that my cabling is going to work as it's supposed to. It's called structured wiring. Our goal of a structured design is maintaining the proper standards, getting the most from our LAN cabling. Again, if I go by all the guidelines that are out there, my cabling should work, my cabling system should work to support my network as it should, and meet all of these other things that come along. And these other standards like IEEE, IATA, UL for safety, all these kind of get rolled into the standards we use for cabling. So if I follow my standards for cabling, I'm kind of by default following all these other standards that are necessary to have my network work and function. And this is just kind of a reminder of our different standards groups that we talked about back in 120, if you recall. These are all different groups that write standards for certain parts of networks, and a lot of our cabling standards kind of combine some of these together so that when I put my cabling in, it's adhering to the good practices denoted by EITA or IEEE or UL for my cabling system. LAN wiring standards cover everything from electrical to safety, exactly. So if I'm following my cabling standard 568C, if you will, it has a number of these organization standards rolled into it, so I'm following best practices. Should I dream up my own system? No, that's kind of like going out and building my own car. It might work, but it might not work. Okay. Should I use older data or phone wiring systems just to make it work? Probably not, because it's probably not going to work. Should you pick and choose from various manufacturers? Well, this is kind of a loaded question. If I follow standards, I should be able to mix and match some components from different manufacturers, and they should work. But sometimes we know this. I'll pick on a Ford truck. If I have a Ford truck, it's probably going to be best to put a Ford part in the Ford truck. Probably. Not always, but probably. So a lot of times when you're doing cabling, you're going to run into a company that comes in to install cabling in a building uses all brand X, brand Panduit components in their building. So everything matches, everything fits, everything works, everything is kind of certified to a level. It kind of works easier, it works better for them. So as I said, it's kind of a loaded question. I can in some cases pick and choose from manufacturers, but a lot of times what works best is if you stick with one and use all their products, so everything kind of matches, fits, works, certifies, that sort of thing. The best way to proceed is use our standards to our advantage. That way you get the most out of it. I pick a structured plan. Again, we're going to do this for our project. I stick to the standards as I'm installing it. I use the proper cable category and all the components. I stick to my maximum lengths, which we'll get to. I use the correct jacks and connectors for that category. I use the proper techniques. And I test and document. Well, yes. And actually, we're going to do all these pieces as the semester goes in labs and on our projects. We're going to do all these as the semester goes. The advantage of this is the properly installed cable system will never contribute to connectivity failure. Well, that sounds like a far stretch, but really, if I install my cabling correctly in my building, it really shouldn't be the problem of the cabling if there's a network failure. It's usually going to reside in some other aspect of the network, like down here, user cords are part of the cable system. That's the patch cable that goes from the wall to your computer. Typically, the fault, if you have one in your cabling system, is that patch cable that somebody's been running over with their chair for 6 months or whatever it is. That's usually where the fault is. It's not usually in the cabling that's installed in the walls or above the ceiling. That's what they're getting at with this statement. So it seems kind of far-fetched, but that's where they're going with that. Other advantages I'm going to get is if I install a cabling system and then some other group comes in 5 years later to add to it. If I did it to standard, they should be able to recognize what's done and add onto it and make it work. If it's properly installed, I'll be able to troubleshoot these problems quickly and easily. Yes. A properly installed system will meet fire and electrical standards for building codes and that sort of thing. Yes. Okay, so the idea of following these standards is really a lot of benefits, ones I don't often think about, but a lot of benefits that I get in my network. This brings us to a couple terms they throw at us. One of them is being installability, the functionality of my network. Installability means easy to install and maintain. My best choices support present needs and future needs. Easy to properly install, use a minimal amount of special equipment to do this. So my installability is really kind of is it easy to install and maintain day by day? Well, a standards install should be. A lot of the choices that are made in here are personal preference or customer preference. Again, I think I jumped right by back here. What exactly faceplate colors do I use? What exactly jack types I use? Well, some of these choices are made by the installer, like we'll use all Leviton jacks and all Leviton patch panels and those sorts of things. But the customer could choose faceplate colors. I want that jack to be blue, so it's for phone, or orange for data, that sort of thing. Those are some things that can be made. That's customer preference, if you will. But some other choices that are made might affect my system cost. Again, if I install a newer type of jack that's easier to terminate, well, it might cost a few dollars more per jack to use this easier to install jack, but overall it might actually be cheaper because my labor is usually a high cost in my project. So if my workers that are installing it all can get 5 more jacks done an hour with this new type of jack, you might actually save money in the long run by buying that more costly jack that's quicker to install. So there's different choices that installers use to install your cabling system, and these are all parts of that. These all affect the system cost. We look at an outlet jack and go, wow, $5 or $10 a jack, but if you're doing them all day long, a $10 jack that I can install quicker might actually save money in the long run than the $5 jack that takes a long time to install. So your installer makes some choices for maximizing their network install for their customer. Another term they introduced to us is reusability, the scalability or adaptability of our network. Technologies are going to change. They are going to, if you think back in time, we used to have 10 megabit, then 100 megabit, then a gigabit, and it won't be too long down the road till we start thinking about 10 gig to the desktop. Well, as I do that, that affects what's happening at my layer 1, my physical layer, my cabling layer, if you will. As we go from 10, 100, 1000 to 10 gig, the cabling needs to change to support that. So the reusability of my network is, as I'm installing my cabling, I'm thinking about where I'm going to be in 5 to 10 years. And have I installed a grade high enough to support gigabit or 10 gig down the road? So I need to be thinking now and future upgrade of my network. Will it support it? And the other thing I'm thinking about is the useful life of this. If we own the building, we might install the highest grade possible because we're going to be here for 20, 30, 40, 50 years. But if I'm leasing the building for 5 years, I'm not going to install the latest and greatest because by the time I do, we're not going to get the use out of it. So I might install exactly what I need today. Another thought here in reusability is this overwire idea. Again, if I need 2 outlet jacks in an office, but we're going to be in this building for 20 years, I might actually put 4 drops in that office, so I have a couple extra for future. It's cheaper to put the outlet jacks in now than it is to come back later, get all the tools out, get all the equipment out, run all the cabling down, terminate the outlets. It's actually cheaper to put those extra outlet jacks in now than it is to come back later and do it. So overwiring is key. And again, I should be installing so that it meets at least one level above where we need to now. If I need 100 meg now, I should be installing capable of 1000. If I need a gigabit now, I should be installing capable of 10 gig. That way we can upgrade down the road and not have to tear all the cabling out and start all over. All right, I'm going to come back in the next podcast and continue on.